Hey guys, Mr. Bowman here. Today's learning objective is in red and we are learning to find the area of a triangle. I suppose that's the key thing for today, area of a triangle using trigonometry. So I've got the formula we're trying to work with here. So you can see it's a bit more complicated than 1/2 of base times height. But the area of any given triangle is 1/2 of A times B times sine big C. So I just want to emphasize that is sine big C because it relates to an angle. I've also got 3 questions for us, 1, 2, and 3. But before we get into those, let's try to think, well, where does this formula come from? Let's try to prove the formula and then we'll move on to the questions. So most of these proofs always start off with a triangle, like so. And let's say that there is angle C, and maybe that makes that one up there angle B, and that one there angle A as well. So we've got A and B. The opposites, that would be little a, that there would be little b, and that there would be little c. So that's what we're working with. I'm just going to rub out a few bits of information here. So we don't need little c anymore. We don't need big A, and we don't need big B. So they're gone. And the area of this triangle would be the old 1/2 of base times height. And what we're going to do is we're going to use our trig rules. Well, what should the height of that triangle be? And if you use the internal angle given and the hypotenuse, you could come up with an expression with our trig terms to find that. So let's have a look. So that means the little b is going to be the hypotenuse. The height, well, that's going to be the opposite. And that's what we're looking for. And we're not really fussed about the adjacent, which would have been down the bottom. So the height of that, so that tells us we're going to be using O and H, which is the sine rule. So sine angle is equal to O over H. Sine little c, sine big C, and that's from the angle in that right angle triangle, is equal to O. We don't know O, but we know that's going to be divided by little b, which was the hypotenuse. And we can then rearrange it. O is going to be equal to little b times sine c. And that little b moves to the other side as multiplication. So that means the height of this triangle, in terms of our formula, is little b times sine c. So let's now substitute all of that into our equation. So 1/2 of the base, and the base of our triangle is A. The height of our triangle, we know it's going to be b sine c. B sine c. And if you reconcile that, there is our formula that we would have used to start off with, that we chatted about. So area equals 1/2 of A times B times sine big C. So hopefully that mini proof holds some bit of value, and it just means we'll hopefully be able to apply this formula with a bit more confidence. So I'm just going to rub out most of our workings. I'm going to leave the formula and our right angle triangle. And then we're going to get into our 3 examples, and we'll have a chit chat about how we can apply the formulas. So the way the formula works, so let's change pen color, let's get into blue. So in a triangle, you'll be given an angle. We have to label that given angle big C. The 2 sides that join together to make that right angle will be A and B. 2 sides that join to big C are A and B. So that's just one note about how we can label our triangle to help us solve certain questions. So let's get into a couple of examples. So we'll start off with question 1. We've just chatted about it, but we need to label the given angle big C. So we've been given this 35 degrees, which means that angle there will be C. The 2 sides that join to make that angle, they will be A and B. What we're then going to do is we're then going to start working. So let's just do it at the top here. So the area of this triangle will be equal to 1/2 of AB sine C. So that's going to be 1/2 times 12 times 15 times sine 35. Sorry about the bad pen there. And when you put that in your graphics calculator, you should get 51.6 degrees, and that there was rounded to 1 decimal place. So hopefully that first question made sense. We're now going to move on to our second question, and the issue with this question is we haven't been given any of those internal angles to solve. But what that does mean, we have to use the information we've been given to find out one of the internal angles. And then once we've found out one of the internal angles, we can then go away and figure out the area of this triangle. So straight away what I'm thinking, I've been given 3 sides, and straight away I'm thinking cosine rule, because the cosine rule requires 3 sides and 1 angle, and you're allowed to not know one of them. So we know all 3 sides, and we don't know that 1 angle. So I'm happy to use that. So now let's think of the cosine rule. So let's say we're trying to calculate this angle down the bottom, big A. So that means the opposite would have been little a, and the other 2 sides, doesn't matter which way around they are, they would be little b and little c. So if we start our working with the cosine formula, so a squared will be equal to b squared plus c squared minus 2bc times cos big A. From there, we can substitute in all the values. So a is 8. So 8 squared is equal to 10 squared plus 14 squared minus 10 times 14 times 2. Don't forget the 2 from the front. And then we're going to go times cos A. And cos A is what we're trying to find out. From there, we can go ahead and calculate all the square numbers. So 8 squared, well, that's going to be equal to 64. 10 squared is 100. 14 times 14. I'm just doing that on my calculator now. So 14 times 14, that there is 196. And then we're going to go 10 times 14, which is 140, times that by 2, which is 280 of cos big A. We're then going to add all of these together. So 64 will be equal to 296 minus 280 cos big A. We can then use our algebra and our rearranging from there to finish this off. So 64 minus 296, that should be equal to negative 280 cos big A. So 64 minus that, well, that comes to negative 232. That's going to be equal to negative 280 of cos big A. So we're going to go negative 232 divided by negative 280. That there will be equal to cos big A, which means A will be equal to cos, or the inverse cos, 232 divided by 280, which equals 34 degrees, and that there was rounded to 0 decimal points. Now that we've got that, I've cleared all my cosine working, we can get back into our area formula that we're trying to learn. So that angle there is 34 degrees. And we know that there we call that angle C. Little a and little b, they join together to get angle C. And we'll be able to use that information to find out the area of this triangle. So the area is equal to 1/2 of A times B times sine big C. So that's going to be 1/2 times 10 times 12 times sine 34. That there's going to be equal to 70 times sine 34. And when you put that in your calculator, you're going to get 39.1 centimeters squared, and I've rounded that to 1 decimal point. And just a friendly note, centimeters squared is the units because we've now switched to area, so we must use the correct area units as well. So hopefully you found that second question more useful. That was a bit trickier, using the cosine rule to help finding out the information. What I'm going to do is I'm going to pause the video. I'm going to clear our existing question 1 and 2 working. So if you haven't got that, make sure you get it down. And then we're going to get into our final question, question 3. Okay, and the last question, question 3. This one's a bit different because we've actually been given the area. So we can see that triangle ABC has an area of 88 centimeters squared. And we've been told to try to find the angle B, then A, and then C. So we're trying to find that angle that sits within there. So we're going to call that angle, and then that's what we're trying to find. So I guess the first step with any question, we need to write down the formula that we're going to use. So in our case, so question 3, the formula we're going to use, we're trying to find the area. That's equal to 1/2 of A times B times sine big C. So we then go through and label our triangle. So that there is angle C, and we're just going to call that X because that's our unknown by the looks of it. Within A and B, they join together to make that angle. From here, we just substitute into our formula. So we know that the area is going to be equal to 88. So 88 is equal to 1/2 times A, which is 15, times B, which is 17, times sine C. When you get that into your calculator, so we're going to go 15 times 17, that equals 255, times that by 0.5, that is 127.5. So 88 will be equal to 127.5 times sine C. We'll then move the 127.5 over as division. So 88 divided by 127.5, that's going to be equal to sine C. And that there means C, which we probably should have called X all along actually. So let's call that all X because that's what we've labeled it. So X will be equal to inverse sine of 88 divided by 127.5. And when you put that into your calculator, X is going to be equal to 43.6 degrees, and I've rounded that to 1 decimal point. And just for completeness, because they've asked us to do angle BAC, I'm just going to do a little summary. Therefore, angle BAC is equal to 43.6 degrees, 1 dP. So hopefully that last question was found useful. What we can do is, if we're given an area, we can actually work backwards to find out any of A, B, or big C. So we found the angle here, but you may also be required to work back to find out sides A and B. So that wraps up today's video, guys. It was a relatively long one, but we went through heaps of stuff on how to apply this new area of a triangle rule. Now that we've done this, make sure you get all the examples down, and then let's get into heaps of practice.